In this technical corner, we are going to be discussing high-speed face milling of Inconel 718, and I'm joined by Peter Ward from NTK Cutting Tools. Welcome, Peter.
Thanks, Joe.
Now, Inconel, what an awful material it is. Now, high-speed face milling of Inconel 718 with ceramics.
Yep.
What kind of benefits will you get?
Well, to be honest, face milling, we've done a lot of development, especially in recent years, on especially our Cylon materials. And one of the biggest successes we've had is using Cylon inserts for the face milling of mainly Inconel 718, but other heat-resistant superalloys as well. It's been one of the biggest successes. The huge advantage is the cutting speed. It doesn't actually work at lower speeds, so we need at least 600 metres a minute.
So 600 metres per minute doesn't mean a lot to me in regards to, can you give me a comparison in regards to what you would kind of do it with carbide?
Yeah, I'm not a carbide expert, I should say, but if you think about, I don't know, between 50 and 100 metres maybe, you'd be milling Inconel.
So there's a massive increase
change,
in speed.
Yeah.
But what about depth of cut?
Depth of cut, we normally use round inserts. So depth of cut, we're talking 2 to 3 mil, something like that. If you're using a 12 mil round, which would be our standard approach to ordinary face milling on Inconel, we'd do about 2 or 3 mil, something like that. But if you imagine, and roughly, just as a comparison, if you're using, say, a bog standard 125 milling cutter with a normal ceramic feed rate, you're probably talking about 3 metres table feed a minute on Inconel. That's quite a huge amount if you think about it. So again, it's like all ceramics. It's not a slight improvement. Where it works, I'm not saying we can do everything, it's a huge change. It's a seed change in your production.
So on Inconel 718, which this technical corner is totally based around, if you can make these huge savings, not minutes, maybe hours.
Yeah.
Why isn't everybody using this ceramic technology? Why aren't more people using ceramics, full stop?
Yeah, I think in terms of the face milling, it's not always easy to find the right component. The component is an important factor, Is it the right kind of application? Have people got the right machine? Because obviously, if you're running, say, 800 metres a minute with a round negative insert, you're going to pull a bit more power than you would with say a positive rate carbide. So there are limitations, work holding, things like that. So there are limitations, but as long as you find, if all things come together, the part, the machine, and the application, then you can have these huge successes. And say it's not a small change. It transforms your production.
So you mentioned factors and applications. Can you give our audience an example of the right application in which you would expect massive savings?
Yeah, I think it's anywhere on aerospace components where there's a fair amount of material to remove. That's when we score big. So things like manifolds, perhaps, torsion boxes is another one. Maybe roughing out of turbine blades. Anywhere where there's quite a bit of material to remove, that's where you really score. So
massive savings. Now, we mentioned the barrier to entry, which is potentially education. In regards to the programming of the face mill, what kind of differences would there be there?
To be honest, with face milling, it's a lot simpler than turning components because there's one tool involved basically. But it does come back to what we always talk about with ceramics, using the strongest shape you can use of ceramic insert because of our, we have lower breaking strength, so we need the strong shape. So roughing, basically, you talk about RNGNs. That has huge advantages. It's our strongest shape. It's double-sided insert. You can get, depending on depth of cut, maybe 4 or 5 indexes per side. So it starts to become a very cost-effective type of insert to use too.
So you're getting cost-effective benefits as well. Now, in regards to the feed and the speeds, that's basically what you would help the client with.
Yeah, absolutely.
And once you've got that nailed down and you've got the complete process nailed down, you'd expect the kind of savings that you're mentioning. And just to summarise now really, and just to wrap up, what kind of different grades, or what is the specific grade for Inconel 718?
Yeah, well, normally we'd use the Cylon grades for milling. That would be our first choice. Cylons are the toughest of the ceramics. So obviously they're, perfect for sort of milling, which is obviously an interrupted cut. So all of our milling grades are basically Cylon.
And just to really finally wrap up, you mentioned machine tools and the speeds is one of the factors. If you had a machine tool that didn't or couldn't achieve the speeds that you'd require, could you still get benefits from the ceramic technology?
Ceramics will work over quite a broad range of speeds, from say 300 metres up to 1,000 metres for face milling. So there's a broad range, but if you're forced to use low cutting speeds, stick with carbide, because the advantages become less and less the slower you go. And carbide at those speeds will give you fewer problems. So as long as you can get 300 metres and above, then you have a chance.
Peter, it's been brilliant. It's great to be on this educational journey with you. I've learnt a lot. I hope you've learnt a lot too. Face milling for Inconel 718 with NTK. Thank you, Peter.